Uh, Hello everyone, this is just to explain how transcendental equations can be solved. Transcendental equation, they're something that right now I'm just giving you the example. An equation like x equal to sine inverse x. Solution is not very easy to get, uh, or x equal to log x, or sine x equal to x by 10. All those can be uh, solved quickly if we are able to plot the graph. Using this GeoGebra software, I would like to show you how we can solve those transcendental equations. I mean, they cannot be expressed in the form of polynomial. Right now, at this moment, I am telling you, remember those as transcendental, like x equal to 10x, what trigonometric function mainly involved, maybe exponential function, maybe logarithmic function. When these are involved, then those equations are called transcendental equation. Graphical solution is the best help to get a solution over there. Okay, just I am going to show you one. Say I have an equation y equal to x equal to log x. I want to solve this. What I am going to do here in GeoGebra, I'll put y equal to sine y equal to x over there. I have drawn y equal to x. All of you can see that. Then I plot y equal to log x graph. Okay, these two are not intersecting. You all can see that y equal to x and y equal to log x are not intersecting. If they do not intersect, they do not have any solution. So your conclusion will be here that x equal to ln x, if we set, we will not get any value of x. For no value of x, it will be satisfied. Okay, this concept you remember. Whenever they are asking a solution x equal to log x, your answer will be, as the graphs are not intersecting, so solution is not possible. Okay. Now I am changing these two functions. I am taking, say, y equal to e to the power x graph. You all can see, because negative x-axis is the asymptote, and this goes on increasing with the value of x. This is the graph of y equal to e to the power x. This is mirror image of log x, isn't it? This graph is mirror image of log x. You all can see that here this point of intersection is 1, 0, there it is 0, 1. It is not showing 1, 0 because I have chosen the graph along x-axis in this manner, 0, pi by 2, pi like this. And here I would like to remind you that I have done in the another video there, that y equal to x if I plot, then these two graphs are mirror image of each other. If there is a point on this graph a comma b, on it is going to be b comma a. Okay, so they are inverse of each other. All this you know. Now what I am going to tell you today, is there any solution of y equal to x and y equal to e to the power x? Your answer definitely going to be no, because this time also they don't intersect. In fact, it happens. If the original function doesn't intersect y equal to x, its inverse will never intersect. Okay. So let us go for another one. If I take y equal to x square, all of you will see the solution mentally, that one solution is 0, 0. The other one going to be 1, 1. If we put x equal to 1, y is going to be 1. This point of intersection, if we try to find by using this, that I am trying to get the point of intersection here. I am clicking on this curve as well as on this curve. Okay, this point of intersection, it has come. You can see one point of intersection is d 0, 0 of the two curves, and the other point of intersection is 1, 1. So what will be your answer here? If they have asked you to solve, these two equations, y equal to x and y equal to e to the power x, then y equal to x and y equal to x squared, the solution going to be these 2 points C and D. D has coordinate x0, y0, C has 1, 1. So you will say that the solution to the equation x equal to x square is 0, 1. X is 0 and x is 1. But this is the simplest case. You will see that I am very efficient to get the solution by using my algebraic calculation only. y equal to x and y equal to x square, I can solve, I can tell you the answer. But my question is that if I am choosing different curve, this is y equal to x square, and then I have y equal to e to the power x. See what is happening there? Are you able to predict the solution here? This point of intersection, can you see? You can't see. If you plot the graph, then you can predict the solution here. Here I can tell you, because I am using GeoGebra app here, I can tell you the point of intersection, clicking on it and clicking on it. Then this point of intersection is E. E has coordinates C minus 0.7, 0.49. Okay, you don't have GeoGebra, you are not able to apply it in your exam, but you all can plot the graph of y equal to e to the power x. You all can plot the graph of y equal to x square. From there you can predict a solution over there. Your answer will be the two equations e to the power x, the equation, the transcendental equation e to the power x equal to x square. There is a solution I can predict. A real solution exists over there. This is the concept I share with you in the beginning of the session, that whenever they ask you to solve two equations, then you take where two or more variables are involved, you take one of them as the function y, the other one as another function y, another function, you plot them, their point of intersection you will get. You can do it manually, you can understand better with the help of this app. Now my question is to discuss the problems given in your exemplar and NCERT book, how solution can be obtained quickly with the help of graph. Maybe I am drawing with this software. This will help me. This will help me to get it the graph nicely, to predict the solution also very fast. But in exam you have to do it manually. In all kind of exam you have to do it manually. But if the graph is in your mind, without plotting you can state also. Let me do for another one. Suppose I am making all these up here. I am taking this one, y equal to, say I am taking 0.1x, x by 10, and you are asking me to find the number of solutions of the equation sin x equal to x by 10. Sin x I have plotted. If I have given you the interval minus 2 pi to 2 pi, how many solutions are there? I think all of you are able to answer. I will find the point of intersection of the graph sin x and the graph 0.1x. Then between minus 2 pi to 2 pi, all of you can say that number of solutions I am getting here 1, 2 and 3. No calculation is required, just plotting of graph. When you are doing it manually, you have to do it accurate one. But here with this software, I can predict the solution very fast. Okay. This is not to show you the power of this software. This is just showing the power of graph, plotting of graph to get the solution. Okay. Now forget about this. Many of you are able to get solution here also, because you can plot sin x equal to x by 10. This is y equal to x by 10 nicely. You can plot the graph of sin x also. Their point of intersection, all of you can see. Now, if there is a complicated curve, suppose I am taking the graph of these two functions. Say I want to find number of solutions of sin inverse x and cos inverse x. Come back to our problem, NCERT problem. First, if they have asked you how many solutions are there where sin inverse x equal to cos inverse x, you know principal value branch of sin inverse x, you know principal value branch of cos inverse x. That for sin inverse x, all of you can say this will be from minus pi by 2 pi by 2, and for cos inverse x, this is like from here it is 0 to pi, but as the axis chosen different manner, that's why it is not showing the coordinate along y-axis. Okay. Now they will be intersecting at one point here. All of you can see that this is the point of intersection. So there is one solution of the equation sin inverse x equal to cos inverse x. Okay, in their principal value branch, if we try to solve them, just one solution is predicted over there. Exact solution you cannot say, it is not required from you. You just say how many solutions are there. Your answer will be 1 in the principal value branch of them. Okay. Now go through the exemplar question where they have asked in which interval sin inverse x is greater than cos inverse x. Okay, I am telling you the point of intersection. Let us find the point of intersection here. The intersect part I am plotting here. This is one curve and this is the other curve. They are intersecting at this point. Coordinate of the point F, you can see it is 0.71, 0.79. So x coordinate of the point is 0.71. Okay, this is x coordinate 0.71. So the value of x going to be 0.71. You cannot say exact value when you are doing manually, but you can say that solution lying in the interval 0 to 1. One root of the equation cos inverse x equal to sin inverse x will get. And now I think you got the solution to the question the exemplar book have asked you. The last question I told you where cos inverse x is greater than sin inverse x. You will say that cos inverse x is greater than sin inverse x. It is before 0.71. So from this point, from here, from leftmost point minus pi by 2 to this point, here it is going to be cos inverse x is greater than sin inverse x. But beyond it, when you are going from this point 0.71, sin inverse x is going to be greater than cos inverse x. So if they have asked you 4 options, you can easily match, you can easily see what is going to be the solution here. I think you have understood that question. Now we come back to that question where I have to decide which one greater, tan 1 or tan inverse 1. Let's say I am changing these two graphs again. I am bringing tan x and tan inverse x. Tan x graph I am plotting here. This is given tan x. Where have I plotted tan x graph? That you all can see. The tan x graph is plotted in the interval which is known as principal value branch. It is from minus pi by 2 to pi by 2. You all can go through that NCERT exemplar question number 15. It is a solved one. I am trying to give you a better method of solving, although they have explained by the same method, but you can visualize. This is a dynamic math software. Every moment you can explore something. You can see all the solutions in your eyes. That's why I've chosen this one to explain to you. For gx equal to tan x, the graph is this. All of you know. It is minus pi by 2 to pi by 2. They are called asymptote to the curve. My aim is to prove which one greater, tan 1 or tan inverse 1. Let me plot tan inverse 1 in the same graph. This h1x is the tan inverse x. The graph is plotted over there. All of you can see that. Now their point of intersection, if I want to find, I go by the intersect part. Intersect part is there. So click on it. Click on it. See the point they have given, that is 0, 0. Point of intersection, all of you can see, that is 0, 0. But my aim is to get x equal to, 1. For x equal to 1, which one larger? So what I have planned for you, I will be plotting the line x equal to 1. Let me plot x equal to 1 here. That x equal to 1 I type x equal to 1 in the input bar. All of you can see that x equal to 1 is a line which is parallel to y-axis, and if we want to represent it by different color, this is the graph of this one. This is the graph of x equal to 1. All of you can see that x equal to 1 is a line parallel to y-axis. Now on x equal to 1, x coordinate is 1 really, and this graph, this maroon one, is the graph of tan inverse x. When x equal to 1, the y coordinate of tan inverse 1 is what? This much part only, from this point to this point. If I intersect again, if I go by point of intersection that of intersecting x equal to 1 and this one. See, the point H is there. What is the coordinate here? 1, 0.79. So this vertical coordinate is going to be, vertical ordinate is going to be 0.79. Now this part is original curve tan x. Everyone by seeing the graph will see that, sir, obviously tan 1 is greater than tan inverse 1. But I want to check it mathematically. I am taking the point of intersection again from I am intersecting these two curves. Yeah, this point of intersection now showing it 1, 1.56. So the point H has y coordinate 0.79 and the point I has y coordinate 1.56. Which one larger? That 1.56 is greater than 0.79. So your answer going to be tan 1 is greater than tan inverse 1. Okay. Thank you all.